Good morning to all. In this video, we discuss fourth problem, design of spur gear. A compressor running at 400 rpm is driven by a 25 kilowatt 1200 rpm motor through a pair of 14.5 FDI spur gear. The center distance is around 400 mm. The pinion is made of forged steel of static allowable stress 190 MPa and 350 bhn. Gear is made of cast steel of static allowable stress 180 MPa and 300 bhn. Design the gear for safe continuous operation. Check the gear for endurance, wear, dynamic strength. Name the class of the gear. First, note down all the given data. The speed of the gear is 400 rpm. Power transmitted is 25 kilowatt. Speed of the pinion is 1200 rpm. Pressure angle is 14.5 fdi. Center distance 400 mm. Pinion material is forged steel. Its allowable static stress is 190 MPa. Gear material is cast steel. Its allowable static stress is 180 MPa. Surface hardness of the pinion and gear is 350 bhn and 300 bhn respectively. The question is design a spur gear and also ask the class of gear. Check for the wear strength and check for the endurance strength. First, we calculate the velocity ratio from this equation. From the center distance equation, we calculate pitch circle diameter of the pinion and pitch circle diameter of the gear. To identify the weaker member, again temporarily assume Z1 equal to 20, then calculate Z2. The Lewis form factor for alpha equal to 14.5 FDI, the equation is given here. The Lewis form factor for pinion and gear is calculated. Step 1. Identify the weaker member. To identify the weaker member, we tabulate the column. Then calculate the product sigma naught y. The value whose sigma naught y is lesser is the weaker member and design the same. Step 2. Design. A bit tangential tooth load. The tangential tooth load equation is given. From table 14.7, for the driven mechanism compressor load, the service factor we take CS equal to 1.75. Here we are not doing any assumptions. For the compressor, the service factor is 1.75. For weaker member, N1 value is given, R1 value is calculated. Put all the values in the equation number 23.87b. The value of Ft is 3481.8 Newton. That is the equation number 1. B bit tangential tooth load from the Lewis equation. The equation is given here. For weaker member, sigma naught 1 is 190 MPa. Select face width is 10 moduli. circular pitch is 5 m. Again, the Lewis form factor y1 is in terms of moduli. Calculate pitch line velocity. Here the pitch line velocity is less than the 20 meter per second. Then we use velocity factor equation is this one. Then calculate velocity factor. Put all the above values in the equation number 23.93. Now the value of Ft is in terms of moduli. That is the equation number 2. Now equate the equation number 1 and 2. We get the equation number 3 in terms of moduli. By trial and error method, find the moduli m. Now select standard moduli m from the table 23.3. Trial 1. Select moduli equal to 4 mm. Put moduli 4 in the equation number 3. After calculating, we get LHS is less than the RHS, and the selected model is not suitable. Trial 2. Select model equal to 5 mm. Put that value in the equation number 3. After substituting, we get LHS value is greater than the RHS, hence the selected model is suitable. Next, C bit. Check for the stress. Calculate allowable stress and then induced stress. If induced stress is less than the allowable stress, then the design is safe. Finally, we write model equal to 5 mm, face width is 50 mm. Calculate number of teeth on the pinion and number of teeth on the gear. Step 3. Calculate all important geometric parameters of the tooth profile by using the equation given in the table 23.1. Step 4. Checking. A bit. Dynamic tooth load FD. The dynamic tooth load equation is given here. In this equation, only the C is unknown. Refer figure 23.35a. For pitch line velocity 12.5664 meter per second, the error F is 0.03 mm. Now the value of C is estimated from the table 23.32. For the error 0.03 mm, there is no value of C. Hence, we do interpolation method or by cross multiplication method. Then calculate the value of C. Substitute all these values in the equation 23.155. We get tangential tooth load equation. B bit, wear load. The wear load equation is given here. Calculate ratio factor. D1 value is already calculated. Face width value is already calculated. The K equation is given here. Calculate surface fatigue stress. where HB is average surface hardness for the gear pair. Calculate HB value. Then substitute this HB value in the equation number 23.168. Then calculate sigma FSC value, where E0 is the equivalent Young's modulus. For the steel, we know the Young's modulus is 206 GPa. If you take 210 GPa, no problem. Calculate equivalent Young's modulus. Put all the values in the equation number 23.16. We get the K value is 1.18226. Put all these values again in the equation number 23.160. Then calculate wear load. As FW is greater than FD, the design will be satisfactory from the standpoint of wear or durability. C-bit, endurance strength. The endurance strength equation is given here. The capital Y is pi Y1, where Y1 is the less form factor of the weaker member. Calculate Y1. Then calculate capital Y. From the table 23.33, for surface hardness 350 BHN, the endurance limit value is 620.5 MPa. Put all these values in the equation number 23.158. We get the value of endurance strength. As endurance strength is greater than the dynamic load, the design will be satisfactory from the standpoint of strength. Now find class of the gear. Refer figure 23.34a for model M equal to 5 mm and error F equal to 0.03 mm. The class of the gear is first class commercial gear.